Hi, my name is Chimukangara². I'm happy to share data on behalf of the INSIGHT study team looking at HIV drug resistance among adults receiving either bictegravir or dolutegravir-based ART during rifampicin-based treatment in South Africa. And so the problem we identified is that bictegravir has not been evaluated in individuals receiving concurrent HIV and TB treatment with rifampicin, highlighting a key evidence gap as shown in the image. Given the lack of data on treatment outcomes and the impact of reduced peak plasma concentrations due to drug-drug interactions with rifampicin, as well as complexities of managing HIV-TB co-treatment, this study aimed to evaluate emergent HIV drug resistance among participants enrolled in the INSIGHT trial at baseline and follow-up. And so this was a sub-study of the INSIGHT trial, a phase 2b open-label, non-comparative, randomized controlled trial designed to assess the efficacy, safety, and pharmacokinetics of twice-daily bictegravir or TLD in adults with HIV and TB receiving a rifampicin-based treatment, randomized 2:1 BIC to DTG. Plasma samples were collected at baseline, that's before INSTI treatment, and from any time points with viral loads greater than 50 copies per ml after 24 weeks of INSTI therapy. In all, we genotyped samples from 113 participants using NGS to assess emergent HIV drug resistance mutations. Looking at the participant baseline characteristics, about 2/3 were in the BIC arm, and median viral loads were similar between the two groups. Over 60% of participants had CD4 counts less than 200 cells per cubic millimeter, and only 8 participants had viral loads greater than 50 copies per ml at follow-up, with no difference by study arm. Our results showed that about a third of baseline samples had HIV drug resistance mutations, with similar proportions across study groups. Of the 36 samples with resistance mutations, about 8 in every 9 had NNRTI mutations, most commonly K103N, and there were no major INSTI mutations detected at baseline, and only 4 participants had INSTI accessory mutations, as shown in the bar plot on the right. At follow-up time points, viral suppression rates were high in both groups. Only 8 participants had viral loads that were greater than 50 copies per ml, as shown in the table. Viral loads highlighted in red here mark the time points when HIV drug-resistant genotypes were obtained. Importantly, no emergent INSTI mutations were detected. Only 1 participant in the DTG arm developed an emergent M184VI mutation, which was absent at baseline but present at follow-up. Despite no NNRTI exposure during the study, 3 participants had NNRTI mutations at follow-up, highlighting potential concerns for NNRTI use in subsequent regimens. There were no significant differences in HIV drug resistance proportions between the study arms at follow-up. However, younger age, about median age 27 years, was significantly linked to viral non-suppression, as illustrated in the box plots. Additionally, all participants with HIV drug resistance at follow-up had NNRTI mutations, predominantly K103N, indicating NNRTI persistence. Therefore, this study found that among people with HIV receiving twice-daily bictegravir or DTG-based ART during TB treatment, viral suppression was consistently high through week 48, with no emergent INSTI mutations observed. A high background of NNRTI resistance has been linked to long-term virologic failure on INSTI-based regimens, with potential consequences for future treatment choices. In summary, findings from the INSIGHT study support the inclusion of bictegravir, given its favorable renal and bone safety profile, as an alternative INSTI option in WHO guidelines, and expanding its availability in TB endemic settings. The HIV drug resistance data I showed provide further justification for this recommendation. I would like to thank everyone who made this study possible, including funding obtained from the NIH, South African Medical Research Council, and Gilead. Thank you all for listening.